So today, grade 11s, we're going to be continuing on with the stomach. So we've talked about the different structures that led up to the stomach. We talked about the mouth and the pharynx and the esophagus and how the mouth starts both mechanical and chemical digestion. So mechanical digestion being the teeth chewing and grinding at the food. The chemical digestion starts when the salivary glands secrete saliva, which has salivary amylase, which starts to break down starches, and that's found in those carbohydrates. We talked about the tongue helping to move around the food and creating the bolus of food, which is a mix of saliva and the chewed up food, so that it is easier swallowed. It goes through the pharynx and then into the esophagus, which uses muscular contractions, and it's called peristalsis, to move that bolus of food down the esophagus and then into the stomach. So just a refresher that the end of the esophagus, there's a sphincter there that opens and allows, or I guess it would relax and allows for the food to enter the stomach, and then contracts so that there's kind of breaks up the amount of food that's entering the stomach at one time. So now that we've talked about all that, kind of refreshed our memories, we'll talk about the stomach. So it's a thick-walled organ on the left side of the abdominal cavity. It connects to the esophagus above and the first part of the small intestine called the duodenum below, or duodenum. The stomach can expand, and folds of the inside of the stomach are called rugae, and they disappear. So what you have your stomach, and there's a whole bunch of folds in it when it's small, and those are called rugae. The stomach can expand, so when it's there's lots of food in it, there's lots of gas in it, the stomach expands, and those rugae disappear. So it just allows for more surface area, and it allows for your stomach to expand. If your stomach couldn't expand at all, you'd have a very hard time when you were eating. If you potentially ate a little bit too much, your stomach could actually perforate or break, and you'd have all of that stomach contents such as hydrochloric acid, which is not good, entering your body. Because currently your stomach is actually lined with a mucus that doesn't allow for the hydrochloric acid to eat away and break through that lining. So anyways, the stomach stores food, it mixes food, and it moves food. So it uses both mechanical digestion and chemical. Mechanical digestion happens through the churning and mixing of food. So there's a whole bunch of movement in the stomach. It kind of contracts in different places and causes food to mix up, and that can help break it down as well. That kind of churning could break pieces off of food, and yeah. So that's the churning and mixing of food, which would be mechanical digestion. And then the chemical digestion, we're going to look at another one of the digestive enzymes. It kind of needs its own page, so we'll take a look at that. Maybe, if I can click to it. There we go. So the chemical digestion in the stomach is based around pepsin, or our second digestive enzyme. So chemical digestion in the stomach is the start of proteins being broken down. So salivary amylase in the mouth broke down, or was the start of the breakdown of starches and carbohydrates. Chemical digestion in the stomach is the start of proteins being broken down. So the stomach has a compound called pepsinogen, and that's waiting in the stomach. When the stomach releases gastric juices containing hydrochloric acids, the pepsinogen converts to the digestive enzyme pepsin. So we don't start off with pepsin, we start off with pepsinogen. It then reacts with the hydrochloric acid and converts to pepsin. Okay, so then here is our formula for what happens with pepsin, the digestive enzyme. So we have proteins mixed with water. Again, with the help of pepsin, so this is neither a reactant or a product, it's just an enzyme that aids and helps this process go along and move quicker. So proteins and water with the help of pepsin breaks the proteins down into peptides. So the final product of protein breakdown are peptides. These are too big to be absorbed and must be broken down again later. So that's very similar to our breakdown to maltose, right? So salivary amylase worked on the starches and broke it down to maltose, and so maltose was too big to be digested, too big to be absorbed, and this is the same thing as peptides. Those are too big to be absorbed into the body, so we'll have to go through a process of breaking down again. But we need these first two steps of salivary amylase breaking down the starches and the pepsin breaking down the proteins so that those molecules are ready to be broken down again later in the small intestine. Okay, so make sure you understand this. Proteins start in the stomach, starches or carbohydrates start in the mouth. So we know those two digestive enzymes. There's 7 in total, so make sure we're getting these ones understood. Make sure you know these how these ones are working and where they are working. So a little bit more on the stomach. The stomach walls are very protected from the hydrochloric acid by a layer of mucus. So we talked about that a little bit earlier, just that the stomach is a very acidic environment. It has to chemically break down those foods. We need that hydrochloric acid to activate that pepsinogen. So it's a very acidic area of your body. So there has to be that layer of mucus that stops that hydrochloric acid again from breaking through or perforating your stomach and leaking into your body. That wouldn't be very good for you. So just a summary here. After the bolus is broken down and the proteins have been turned into peptides via pepsin, which started out as pepsinogen before HCl was added. So in this stomach, there is pepsinogen floating around. Gastric juices are added, which contain hydrochloric acid. That pepsinogen transforms into pepsin, which breaks down protein into peptides. So all those P-sounding words, pepsin, pepsinogen, peptides, proteins, those all go together. So that can help you remember that as well. So after all of that has happened, and there's a good breakdown, where did my mouse go? There it is. So after they have entered the stomach, all of that breaking down has happened, they get to right here. There's no more bolus. We have now moved on to a liquid called chyme. You can see that right here, C-H-Y-M-E, chyme. This liquid is moved into the duodenum or the duodenum of the small intestine. So that is this first kind of branch right here. Okay, it's really important to know this branch because there's a whole bunch that goes on here that we're going to be learning about next. And just understanding that the duodenum is part of the small intestine, but it's a very unique branch of the small intestine. So know that. Okay, so again, this liquid is now called chyme, and so the chyme enters the duodenum via this pyloric sphincter. So again, we had a sphincter here that allowed food to enter the stomach via the esophagus. There's another sphincter here called the pyloric sphincter that opens and closes so that a whole bunch of, it's not just all of the contents of the stomach are entering into the duodenum or the duodenum. There's little bits of it entering at a time. So there's a sphincter right here. So that's all we're going to cover for today. Make sure you're understanding how these first parts of the digestive system work, because coming up is going to be the small intestine, and that has quite a bit of information. So understand this before we get into the rest of the digestive enzymes, how they work, and how the duodenum works.